Hello wonderful person, this is Anton, and today we're going to discuss some of the recent updates in regards to these bizarre worlds referred to as Hycean worlds, mostly because recently there was a story that went viral in regards to the potential discovery of life on one of these distant exoplanets. And here we're of course talking about the K2-18b claim that was basically mentioned by every major media source. You can learn more about this in one of the videos in the description. But in a nutshell, despite the claims from Cambridge University and the way that media presented this, right now the enthusiasm for discovering life on this exoplanet is basically a little bit too much. We'll actually talk about this next week because there have been some other updates, but here even the famous Sarah Seeger, who was actually graduate advisor for Niku Madhusudan that published the paper behind this claim, basically stated that in this case, enthusiasm is outpacing evidence. Or in other words, there's obviously a lot of exuberance and a lot of excitement, but the evidence is just not there. Because in this case, this is probably just one of the possible interpretations of the data collected from the James Webb Space Telescope. And so because of this, I wanted to discuss a relevant claim coming from Niku Madhusudan when he actually proposed the idea behind Hycean worlds. Basically these really bizarre planets, larger than Earth but smaller than Neptune, that would contain an extremely thick hydrogen atmosphere, but also an enormous global ocean. Here he presented them as these enormous ocean worlds that he also believed might exist everywhere, just because of how common mini Neptunes are in general. And so in 2021, he coined the term Hycean, or Hycean planets, basically hydrogen ocean planets, with the one he examined the most being K2-18b. And so according to his proposition, or I guess according to this narrative, here our galaxy might be actually filled with these really bizarre, extremely large ocean worlds containing enormous oceans, but also containing conditions that could be hospitable to life, at least some types of life such as microbial life. And at least one of these Hycean worlds, K2-18b, he now claimed contained life after all. This was basically that claimed detection of DMS or dimetyl sulfide. And yeah, once again, check out the videos and stories in the description if you'd like to find out the details. But K2-18b was just one of several candidates proposed to be somewhat similar. As a matter of fact, there are at least 3 more. TOI 732c, where TOI stands for Test Object of Interest, also TOI 1468c, and the most exciting one, TOI 2070d. And back in 2024, Madhusudan himself proposed that TOI 2070d was very likely also a Hycean planet, another large ocean world with possibly also conditions supporting life. That was the claim from the paper he wrote in 2024. And because these planets were just as exciting as K2-18b, a lot of researchers wanted to take a look at these planets with the James Webb in order to see what's going on the surface and in the atmosphere, and to most importantly see if they can also find additional signs of potential life, such as maybe DMS again, I guess. And here, TOI 2070d was actually even more exciting. It was around a relatively quiet star, and it also contained 3 sub-Neptune planets, with maybe even all 3 being kind of similar, and maybe even being these ocean worlds. But it was only C and D that were the most likely candidates to be these Hycean worlds. 270d was the strongest candidate. This was a planet 4.2 Earth masses and approximately 2.1 Earth radii, and was orbiting a red dwarf star every 11 days, which was actually close enough to have really solid atmospheric observations. And while the initial insights suggested, once again, hydrogen-rich atmosphere and maybe evidence of water in the atmosphere as well, which of course meant that we had to take a look at this planet again. And this is what was recently done after years and years of speculations. This was recently reported by Christopher Glein and the team right here in a study deciphering sub-Neptune atmospheres, insights into geochemical models on TOI 2070d, an extremely thorough analysis of the atmospheric composition that focuses on comparing various models to what was actually seen, and even focusing on the exact amount of stuff detected and explaining why certain things were actually missing. And this whole analysis is based on what's known as thermochemical equilibrium, basically inferring conditions for how certain chemicals can form and what pressures and temperatures are required to create these specific concentrations. And while these new observations first of all reveal that this planet is strongly enriched in both carbon and oxygen gas in comparison to hydrogen, but its nitrogen is extremely depleted and possibly even missing. And this was actually a mystery for quite a while now because compared to previous assumptions about these planets and compared to what we see around Neptune and Uranus. Here, it was actually believed that it's going to have a lot of ammonia. Ammonia contains nitrogen. And ammonia is expected to be present in Neptune-like planets, but for some reason, warm sub-Neptunes or even hot sub-Neptunes seem to lack it, with previous models suggesting that there should be a lot of it because of really hot atmospheres extremely rich in hydrogen gas, and especially if there is some kind of a global ocean, as previously claimed and as suggested by studies in regards to these being Hycean worlds. But the exceptional modeling and the explanation in this paper basically presents us with something entirely different. And good news, it might be a rocky planet. Bad news, it's an extreme rocky planet. A giant rocky planet covered in extremely thick hot atmosphere that seems to contain a magma ocean. And so yeah, this is maybe a lava planet. And it's really because of this lava that scientists can now explain why it doesn't seem to have ammonia. Because here ammonia is depleted through a combination of planetary processes and basically turns into nitrogen gas at high temperatures, while then combining with the superheated magma ocean on the surface of the planet. And well, the thing is, the observations from the James Webb seem to actually match this model directly. But naturally, this planet would be way too hot for the actual ocean to exist. And instead, it seems to contain a very unusual gas equilibrium in its atmosphere, specifically carbon dioxide methane equilibrium, that seems to occur at very specific temperatures between 900 to 1100 Kelvin and at pressures of 1 to 10 atmospheres. In this image, it's seen as this hot gas at chemical equilibrium, which essentially creates this very hot and very unusual atmosphere where there's not a lot of chemistry, and instead the atmosphere achieves an equilibrium where most gases seem to remain in the same amount. And the additional observations from the James Webb also confirm that some of these gases can only exist at super high temperatures, so basically 900 to 1100 Kelvin. Otherwise, these gases should not be possible. But surprisingly, the atmosphere is still enriched in water vapor in comparison to carbon dioxide. Here, this is explained by a process known as water-gas shift reaction, with pretty much every gas detected by the James Webb explained in the same way. And so, in a nutshell, this giant rocky planet, covered by extremely hot, thick atmosphere, seemed to explain these planets much better than the Hycean planet hypothesis, which is also one of the conclusions in the paper. Here, the results imply that the Hycean hypothesis is currently unnecessary. And though they don't disagree they might exist, the main conclusion in this paper is that K2-18b and TOI-27d are not Hycean worlds. They're more like high magma worlds, or I guess high lava worlds. Oh hey, I like that. High lava. Basically hydrogen lava worlds. Very hot rocky worlds with a magma ocean covered by extremely thick hot gas. And here, even the upper atmospheric conditions seem to be kind of hot. 400 Kelvin is above the boiling temperature of water and is about 120 Celsius or 260 Fahrenheit. But because this planet is so close to us, this is still one of the most exciting such objects because it allows us to understand exactly what these types of planets are, and of course helps us understand if life can maybe exist here. Right now, it doesn't really look so, because this is more of an extreme version of Venus. But because these sub-Neptunes are so common and so different, for all we know, maybe somewhere out there might be a Hycean planet after all, just not one of these. And though some, I guess, could be habitable, we have no evidence of this yet, and we have no evidence that any of this exists either. Here though, the evidence for the extreme hot world is pretty strong. And so yeah, here we have basically this high lava planet. Superheated ocean, molten rock, very hot, thick atmosphere, and smells pretty bad. But because there are going to be a lot more studies coming out due to that earlier claim of life on K2-18b, we're going to come back and discuss this more in some of the future videos. Until then, thank you for watching, check out some links in the description, share this with someone who loves science, come back tomorrow to learn something else. Support the channel on Patreon by joining channel membership or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.